Canada's vast wilderness can challenge even the most experienced outdoor enthusiasts in many ways, not the least of which is the weather. What begins as a beautiful sunny day can turn ugly fast. Getting a weather forecast before embarking on any outdoor adventure can save lives as well as a lot of time, trouble, and expense for search and rescue.
Thank you.
Forecasts are developed by meteorologists who use data from weather stations, satellite images, and other sources to predict the weather for a given time and place, such as the place where you are about to go to play or work in. Automatic weather stations across Canada, like this one in the Whistler Squamish area of British Columbia, use a variety of interesting tools to measure local weather conditions. The data provided by these on-the-ground weather monitoring tools helps meteorologists to maintain the accuracy of their forecasts.
When windstorms are headed your way, it can be hazardous out there.
One of these tools is a snow depth sensor.
This equipment is used to measure the depth of snow on the ground, in addition to the freshly fallen snow that would happen hourly, and give us a running tally of how deep the snow is.
The sensor uses sound to measure the existing snow depth, along with new snow as it falls. This space-age looking device is an all-weather precipitation gauge. It catches snow or rain in a funnel at the top of the device and weighs it in a tray below. The amount the precipitation weighs determines how many millimeters have fallen.
And this information is sent out to the forecasters to help verify the forecast and just how heavy the rain or snow is falling.
When the wind is blowing, it will affect the amount of rain and snow captured by the precipitation gauge. To measure actual precipitation in these situations, a wind sensor is set up near the gauge to record wind speed and direction to help calculate actual precipitation versus the amount of precipitation caught during windy times. Another, much more complex wind instrument at the site is a wind profiler. It uses an upward-pointing radar and sound waves, or SODAR, to detect wind speed and direction, as well as temperature profiles up to 3,000 meters above the ground. Being able to monitor temperature changes at high altitudes is particularly helpful.
It's a useful tool to help the forecasters know where the freezing level is and how this may affect whether it's going to be snow or rain. Especially here in a coastal location like this, it could change between the two.
Amidst all the new high-tech tools used to measure weather now, you can still find some old technology that's as useful today as it's been for decades.
This is a sunshine recorder, actually one of the few that are still left operational in the country. This particular one is probably made close to 100 years ago and is still operational. That's the unique part about it. It just burns onto the paper behind it much like a magnifying glass, and the hours of sunshine are added up to give the daily total.
While this crystal ball can't predict if there are sunny days ahead, it definitely provides an accurate reading of past ones.
Typical chart. See the hours of sunshine that are burnt onto the chart? This chart will show just under 2 hours of sunshine today.
While automatic weather station data is particularly useful in forecasting local conditions, there's a worldwide system in place that monitors current weather conditions for the entire planet. Twice every day at 0 and 1200 Coordinated Universal Time, formerly Greenwich Mean Time, over 800 upper air weather balloons are released at strategic locations around the world. Suspended about 2 meters below each balloon is a radio sonde, which transmits data on atmospheric pressure, temperature, and humidity as the balloon soars into the outer atmosphere. The balloons are tracked electronically to determine current wind direction and speed. Of the 31 balloons released daily in Canada, one of the chilliest places on record to do so is in the Arctic, near Resolute Bay. Here, Mike White of Environment Canada challenges freezing weather and hungry polar bears to launch the good old-fashioned balloons, thereby giving the rest of the world a snapshot of daily conditions in one of the coldest places on Earth.
It's our complete weather report for our day of Canada.
Releasing weather balloons is not as easy as you might think. Weather itself can be a barrier to launch.
If the wind speeds are in excess of 36 kilometers, visibility less than a quarter mile, I believe the temperature is somewhere around minus 50 or so, we don't have to do the balloon. It's considered, well, you're putting yourself at risk to frostbite. And whiteout conditions, well, you can't see the polar bear that you're trying to avoid.
Personal safety is always a consideration when releasing a balloon in the Arctic. Mike checks in once he's arrived at the station, as well as after the balloon is released.
And when my balloon releases, a second message goes out. If that second release doesn't go out, they'll phone the RCMP, send them our way to check on me, see I'm not out on the ground, falling down, broke my whatever, running from a bear, who knows.
It takes about 10 minutes to half fill the balloon, and that's all that's put in. The gas expands as the balloon rises upwards over 30 kilometers. When the balloon bursts, a small parachute lowers the radio sonde back to the ground.
We've got about 15 minutes or so to kind of hang around and go inside and make sure that sonde's ready to go.
The balloon is now half full, ready for its 5:15 liftoff. They like to be precise. The radio sonde is prepped, then left outside to transmit its humidity and ground temperature readings. It's not only planes that require flight clearance. A balloon needs it too.
How you doing this morning? I'm great, thank you. I'm looking for clearance on a balloon release at 5:15. Thank you very much. We're gonna go launch a balloon. We get our weathers on, and we're going to tie her on our balloon and let her go. Our flights are averaging about 80,000 feet at this time of year. Summertime, we're up over 100,000 feet. If you look at our time, we're good to go. She's after 5:15. And the 5-knot wind, see, it's still moving around a bit. So we'll find our sweet spot. We don't want to hit the building. And here we go. Weather reports. We had a good launch. Now we're going to go enter our ground observations and hope everything's a gringo. All right, well.
Once the balloon hits 400 hectopascals, it's over 7 kilometers up in the air, the minimum altitude for a successful flight, and no other balloon has to be released.
We're at 700 hectopascal now, so it's considered a success. We don't have to put off a second balloon, and my day's over in about 2 hours.
Up here in the high Arctic, Mike's work may be nearly done for the day, but across Canada and around the world, weather data keeps pouring in and the forecasts pouring out. Know what to expect in your outdoor playground and be ready for change. It can happen fast.